Yashvi is an astrophysics Ph.D. candidate at Caltech, specializing in supernova physics. She's leading the commissioning of a new spectroscopic instrument on Kitt Peak National Observatory's 2.1M telescope. She has a strong interest in data science and applying deep learning modules to diverse scientific domains. Thank you so much for being here today. So, first of all, how did you decide to pursue a career in astrophysics? Do you remember a specific moment that made you realize this?
Um, there was no specific moment, but I had a general interest growing up in astronomy, like watching the documentaries and everything. All kids are fascinated by space and the universe. But I started delving more and more, just doing my own, research a little bit and trying to do small projects. Or there are many resources for like high school or middle school children just to learn more about astronomy on lots of these NASA websites and ISRO websites and other astronomy institute websites. So I just browsed around there, and I the interest just gradually grew enough that I decided, okay, this is something I really want to pursue, like scientifically. I always had an interest in science, but astronomy had made a special place in my heart.
That's so nice to hear. And you have a Bachelor of Technology from IIT Bombay. So, how was that experience like for you, and how do you think it shaped your journey further?
It was the most crucial experience that led me here at Caltech. Actually, um, I had in mind that I wanted to do something in astrophysics from like as soon as I actually in high school itself. So initially, I was not planning on giving the JEE examination. At that time, things still used to be separate for separate institutes. Sometimes you had to give multiple examinations for different, like entrance examinations for different schools. So I wasn't planning on giving JEE, but I wanted to pursue a Bachelor of Science or something. And I was trying to find a Bachelor of Science or Technology in Astronomy, but at the time there was only like one institute that offered that in India. So ultimately, I think in my final year of high school, I decided that I wanted to that going to IIT was a better plan because I could do engineering in physics or something, engineering physics, which ended up being my major. But I would also be connected to astronomy people in Mumbai and Pune, and I could find people to do projects with, which would build my research experience. So that's what I ended up doing. As soon as I got into IIT Bombay, I found out, all the professors in the physics department, and there were a couple working related to astronomy and astrophysics. There was one professor working on cosmology, or one professor working on astroparticle physics and related concepts. So I decided to start working with them to get some research experience. But lucky for me, another professor joined the department, the physics department, who worked on observational astronomy. And that was great because through him, his name's Varun Balerao, and he's a very brilliant professor. And he's also, he did his PhD at Caltech as well. So I got to learn a lot from him. Immediately, as soon as he joined, all of the astronomy enthusiasts in the department started working with him. And there were lots of cool projects that we got to work on. There was a new telescope installed in Ladakh, and we got to, see the commissioning process and take part in it, write software and things like that. Then he was also associated with the AstroSat project, which is a scientific satellite that takes data in UV and X-rays. It's an Indian satellite, the first Indian satellite, I think, to do that. And so I started working on data from that instrument and telescope. And that ended up shaping my journey to Caltech eventually.
That's really exciting that once you get the right kind of guidance, it completely shapes your experience and everything. That's
Yes,
awesome.
continue like how I got to Caltech eventually. I applied to do an internship in my third year of undergrad, and uh, I applied to a bunch of places, but ended up coming to Caltech uh, and work on this specific project that was related to a large survey of supernovae. And here I worked on supernovae, and that's how I started working on supernovae. And I got to come back here, luckily.
That's awesome. So, what do you think living in a different country has taught you? And do you have any plans to return to India after your PhD?
Living in a different country, it's really eye-opening experience. And there are good things and bad things about it, but I would say it's mostly a positive experience and a necessary one, because it allows you to be connected to a lot more people than you would if you just stayed in one place, say like or near your hometown. It's always better to, even if you are doing your undergrad in India, I would always say just go to the place that's farthest from your hometown. That's how you should choose. Um, but yeah, it's really important to. It has been really important in networking, and it offers a lot more opportunities for travel that I've experienced. Like it's difficult to travel someplace from India to outside for conferences, but it's much easier if you're in the United States or in Europe. There are so many conferences that are organized in these areas, either United States or European countries. So you get to go to a lot more conferences and interact with other astronomers from around the world, and that could shape your career in significant ways. So I would say it's definitely something one should pursue. One should try to pursue. And then the bad things are, you'll miss home occasionally. You have to do everything by yourself. There's, no one cooking food for you or anything. Things are expensive. Uh, so you have to, make sure, keep in mind where your stipend is coming from, or, you have enough money to actually, for tuition and everything else if you're doing a master's. But yeah, you get used to taking care of yourself. It makes you into a better adult as well.
That's an amazing experience. It completely changes you living away from home because you're
Yeah,
completely alone.
yeah. But you're not completely, like, learn how to make new friends, and you have your own group. You get to do a lot more activities. You get to see a lot of places, which is really exciting. It's the one thing that is the hardest for me is food. I love Indian food, and I think I'm a fairly picky eater when it comes to food. Uh, so I have to either cook mostly myself, or but there'll be some days where I'll miss like some particular thing that I used to be able to get conveniently at home, but now like here I can't. That kind of sucks. But then when I come to India, I eat a lot. A lot of Indian people who are studying abroad do that for sure.
So, how does a PhD program work? And do you have something like a typical day? If yes, then what does it look like?
Um, well, a PhD program, if you have a bachelor's of technology degree or any 4-year degree, then it's easy to directly just apply for a PhD program and do a PhD. You don't need a master's in between. But if you have a Bachelor of Science, which is a 3-year degree in India, then you do need to do a master's before you can apply for a PhD outside. That's usually the case in most places. But and generally it's a 5 or a 6-year program in astronomy in the United States, but it depends from country to country. Some countries have a 3-year program, but they don't have any courses. that you need to do and things like that. So I'll talk just about specifically at Caltech. It's a 5.5 to 6 year degree, depending on what your project is. Sometimes it can be extended a little bit if your project needs it, or you can also finish it early and leave early in 4 years or 4.5 years. But the first year is just you have to do lots of astronomy courses, which is pretty exciting. You in undergrad you don't exactly get to study specifically astronomy. Like you learn physics, depending on your program, you learn physics and math and all the foundational concepts. But when you come here, you get to learn about stars and cosmology, galaxies, all of the interesting stuff. And it's it's difficult. The math is difficult sometimes, which has always been my weakest subject. But it's really like nice to learn all of the courses in detail, in depth. Then the second year at Caltech, you're still doing some of the courses for like half of the time, but the other half you're also TAing for a class. So, and it depends on university to university. Like Caltech is a smaller place, so the classes are small, so they don't need as many teaching assistants. But usually in like bigger places, and the astronomy classes and physics classes are also like 100 people or more. There you need, there the PhD students need to take up the teaching assistant duties a lot more. But luckily at Caltech, we only have to do it for a year, and then we can still, take up the teaching assistant duties if we want, but it's not necessary. And then the last 3 years, you focus on your research, or the last however many years, you focus on your research completely. There are a couple of milestones along your PhD program that help you, track your progress. So after you do all the courses, and the first 2 years, you're working on some project along with it. So at the end of first 2 years, you have to give an exam. It's called a qualifying exam, which tests your knowledge of all the courses that you took and the project that you worked on. And then at the end of around third year, you have to present a thesis plan, which is called candidacy. And you have to present what you're going to do in your thesis, which is another main important milestone in your journey. And after you do a candidacy, then you're officially a PhD candidate. And the remaining years you work on your thesis. It can be different from what you presented in your candidacy. 2 years, it's a long time for plans to change. So it doesn't have to be exact, but you work on all your different projects, you write papers, publish, and then at the end you defend your thesis. That's roughly what a PhD program is. As an astronomer, I don't have a typical day, unfortunately. And sometimes it's nice, like you have the flexibility to wake up whenever you want. You don't have to exactly be in your office at 9 a.m. or anything like that. You can, come and go as you please. Before COVID, many people, like I would regularly go to office and interact, take courses, take classes. But a lot of my work is also, observing with telescopes at night. So I would have to, once a month or twice a month at least, I would have a night where I would have to stay awake the whole night and observe on a telescope. So that would, mess with your sleep schedule, but you correct it. And it's pretty flexible in a day. An average day would be wake up, eat something, do a little bit of work, then maybe go to office, again, eat lunch, do a lot of work, and come back and cuddle with my cats, then make dinner, eat dinner. There is no, it's not too rigid for me. Work is like ingrained everywhere. Even on weekends sometimes. There are days where I have to, maybe finish a paper quickly, or, there's some proposal deadlines. Those days you have to maybe pull some extra hours. Like you have to sleep a couple hours less and just finish something, some task or deadline that you have. But then there are also easy days. If you want to take like there's a long weekend coming and you want to take the Friday off, it's kind of doable.
That sounds, I mean, it's good that it's flexible. You can do a lot of other things in your day and work on a lot of different things. That's really nice.
Yes. The only negative side of this is you have to be really disciplined to get the work done. If you get too consumed by the flexibility, sometimes there are, patches where you won't feel as productive during the day. But yes, so you have to stay disciplined and motivated to keep working through and finishing. You have to set deadlines for yourself. Another thing that's people don't realize at PhD is you won't have as much guidance as you're used to in undergrad or even in master's program. So for maybe the first 2 years, you'll have guidance from your advisor, or while you're deciding your thesis topic and you're shaping what your thesis is going to look like. Then you'll have a lot more guidance, but depending on it's varies too much from professor to professor. Some professors choose to be more hands-off, some are more hands-on, but all of them are extremely busy and they have a lot more students to focus on. So it's not necessary that you'll always get their time. And I think by the end of third year and above that, students end up becoming they start graduating towards becoming independent researchers, which is the goal of a PhD. But that means that you have to set your own deadlines. You have to have your own tasks that you want to finish. You have to come up with your own research ideas and things like that.
Can you share a favorite experience from your journey so far, or a favorite memory?
As you mentioned in the beginning, I'm working on commissioning a new spectroscopic instrument. So my favorite memory so far has been when we first installed the instrument on the telescope, and then we turned everything on, we connected everything, all the electronic hookups, and turned the instrument on, pointed the telescope at a star. And when we got the first image from our instrument, that was a pretty special moment. There's something that I worked on for a while now, and this instrument is now on the telescope, and we are not sure if it's going to work. If the telescope had it was not completely accurate at pointing at something, but luckily we got something in our data, and even though it looked like a unfocused star, it was some data. That means that now our instrument is working, and now the real fun begins, using that instrument and making sure it works perfectly. So that was a pretty nice moment. It got ruined the next week immediately because the mountain where the telescope was, there was a wildfire immediately the next week after we put the instrument on. Luckily, the telescopes and any scientific instruments weren't damaged, but because the wildfire was so intense, it kind of burned the power lines and the internet, lines and everything. So we couldn't do anything with the instrument for the next 4 months. But yeah, I still remember that perfect first light image. Yeah.
It must have been so tense of whether it will work or not. And then the moment you finally get it.
Yes.
That sounds amazing. So research is an opportunity that has even extended to high school students at this point. So what advice do you have for high schoolers that wish to explore this? Are you aware of any opportunities they can explore and how they can start with basic research?
I would say not every school, in India has the opportunity for students to explore something like astronomy, which is not a conventional subject. But I am aware of some of these institutes like Ayuka in Pune. They have some programs for high schoolers where they invite a bunch of high school students and they talk about astronomy. But the most direct research experience that you can get is if you're interested in giving the Olympiad exam. So there's a International Astronomy Olympiad by Homi Bhabha Institute. I don't know if they still conduct it. They probably do. It's a pretty big Olympiad, but they have their, regional Olympiad, then national, and then international. It's a pretty interesting opportunity to learn amateur astronomy as well as, research, professional research in astronomy, both of these things. And it's very fun. Like I've not personally done it. I was not able to qualify in the exam because I didn't prepare enough. But I know people who have gone through this whole. They went to the International Astronomy Olympiad in other countries and competed with other international teams, and they say their experience has been really fun. But even if you clear, I think the regional exam, the Olympiad exam, then you get to visit to one of these, universities, and there they have like a 10-day program or something where they teach you all the basic astronomy concepts, and then you get to and they also have exam there at the end of that 10 or 15-day program. But that whole experience is, valuable enough, even if you don't qualify. And then you meet a lot of people and professors and network with them, and that could spark an opportunity to do some project. You should be on the lookout. All of the astronomy institutes in India would have, opportunity for high school students, like some activity to do, or even just like visiting and meeting with their professors and researchers. They all have like outreach divisions, and these outreach divisions would have activities like that. So you should go to their websites and look these things up. Yeah, so that's something that high school students can do. But more than that, I would just suggest focus on the fundamentals that are being taught in your school. Focus on the science and the math. If you're planning to give any entrance examination for engineering institutes or any science institutes, then focus on that. Once you get to your undergrad, that's where your research journey would begin. I would say as soon as you get to your undergrad, find out all the professors who might be, or when you choose your undergrad, make sure that if you really are interested in pursuing research in astronomy or any other field, make sure you choose the institute that has professors who do this research. And now there are quite a few institutes in India that have, even engineering schools have astronomy professors. So look into that. And when you get there, connect with those professors, start working on research projects. You can also, you should definitely do internships, try to get internships to different institutes during the summer or winter vacations. And, then you'll get the opportunity to travel, outside your country even. You can apply for internships in US or Europe or Japan, Australia. All of these places have, good astronomy, strong astronomy programs as well. So yeah, do research projects, internships, build your research portfolio. And that's what matters a lot when you begin to apply for a PhD.
That's really helpful advice. I'll definitely look into it. What advice would you give to the younger version of you?
I would not give any particular advice. I think my path has been good so far, the choices that I made. So yeah, there is nothing particular that I would say to a younger version of myself. Maybe I would say, be a little more, I don't know, skip a few classes in school, just for fun. I only skipped school once. Uh, yeah, I was not the uh, disobedient child. So maybe, yeah, that would be, have more fun. But otherwise, I think my path has been fairly, the choices that I made, I would make the same choices.
Finally, what unanswered questions about the universe excite you the most?
No, there are too many. And like there's not enough time probably to go into them in detail, but um, there are all the standard questions that are still unanswered. What I would like to know what the answer, like I would like someone else to find out what the answer is. I'm not particularly interested in working them out myself or like working on that kind of research. But yeah, all of the bigger questions, like, people are working on dark matter, dark energy. I would like to see breakthroughs in that field. Gravitational waves is quite interesting. So, what happened after Big Bang is a pretty big question. And there are many people working on different aspects of that. There's like a whole uh, many, many billion years of unanswered, in questions there. And so many people or different research teams and research projects are uh, working towards them. So I would like to just, keep following all of those things up, the bigger questions that I don't work on, but I would really like to see someone answer them. Yeah.
So,
What's a question that you would like to know the answer to?
I mean, I think all those big questions that you read about in science books that you hear scientists talking about, because they sound so exciting because we know so little about it. And the lesser we know about it, the more you can find out about it. So all these big problems are some things that it's just exciting to learn about and see what people are working on.
Yes. Yeah, I would say this. The more you work on, some research in astronomy, the more you realize uh, what it takes. And it's really mostly, collecting data, analyzing data if you're like an observational astronomer. Um, and the excitement has a tendency to go away because you're not working on any of those big questions anymore. You're working on a small part, like a smaller part of a small part of the big question. If you're even like remotely working in that direction, so the excitement has a tendency to go away. But then you also realize that you're gaining more and more skills every day to work on any question that you would like to. Uh, Usually, the big breakthroughs are made by teams of like really, really large people, like thousands of people working together in a big team, in a big project to answer these questions. So, if you're interested in being a part of such team, you can do that. But if you're also interested in maybe answering a small, different question, unrelated, but it's equally interesting to you, it's about some radiation physics phenomena or anything like about some particular star that's behaving weirdly, or a star that exploded in a weird way. So then the more research you do, the more you realize what kind of question that you want to work on or what excites you. So you should always keep pursuing. Right now, you're fascinated by this bigger questions, but in the end, when you end up doing research, those big questions are kind of fade away. You're just doing what you do in the moment. And the research that motivates you is something that you should do. So later in life, if you're not interested in astronomy anymore, even if you do a PhD, you gain lots of essential skills and techniques that are desirable in any other research field. So if you decide one day, oh, okay, I think I've learned enough about astronomy, my curiosity is satiated, now I want to move into a different field that I was excited about, you always have that option. Like you can, if you're motivated enough, I think you can find your way in any other research area. So yeah, it's definitely worthwhile doing PhD.
That's wonderful advice. Thank you so much, Yashvi, for sharing your experiences. I learned a lot from it, and I'm sure my audience did too.
Yeah,
So,
thank you so much for inviting me to this. It's really nice to see a younger student like you, like a high school student, uh, doing this and like having your own YouTube channel to like you're using it to your benefit and helping a lot of other women in science. So it's great to see that you're doing this. Like keep it up.